Hi, my name is Lisa Dumont, and I'm here to discuss present value, future value, and discounting. At the end of this video, you will be able to have the knowledge of present and future value, demonstrate and calculate for future value and present value, and have an understanding of what compound and simple interest is. So before I go on, I'd just like to discuss what these terms really mean. A dollar received now is more valuable than a dollar received a year from now. If you have a dollar today, you can invest it and increase its value. The time of value of money is the difference in value between having a dollar in hand today and receiving a dollar sometime in the future. So why is present value and future value important to us? Well, since money has a time value, we must take this time into consideration when making business decisions. Present and future value calculations are very powerful methods available in making these financial decisions. Once you understand and master these calculations, you can apply these formulas, equations for restating cash flows to make them equivalent in any business decision. The calculations think of them as building blocks for many decisions facing individuals, firms, managers alike. In addition, these calculations allow for many decisions and help to calculate return on investments, capital budgeting, and help calculate return on annuities, and these are just to name a few. So, let's go on. So, what is present value? Well, present value is the amount of money you have today. It is the money that must be invested now to accrue to a certain amount of money in the future when compounded. You will understand what the word compounded means in a few more slides. So in simpler terms, present value is the value today of an amount of money in the future. So what does future value mean? Future value is how much money you have today that grows to a given amount when compounded. It is also explained as an amount of money invested at present and will mature at the end of a given time when compounded at a given interest rate. So why are these two terms important to us? For these situations, businesses need to find a way of weighing cash flows that are received at various times, annually, quarterly, monthly. So there are two fundamental equations that are commonly used, and this video will demonstrate them throughout the presentation. So, to talk about the value of time and money. Today, I will pay you $100, or you can wait 1 year from now and I will give you $110. Which one would you prefer? So let's break this down. If you took the $100 today and invested it into a local bank, say giving 5% interest, you would have $105 in 1 year. Now you need to compute what the present value of that $110 would be. So how you do that is you take the $110 and you divide by the interest rate. Interest rate is 5. That will give you today's value of $104.76. So it would benefit me if I took, or benefit you, for you to take that $100 and invest it at a bank that's giving you 5% interest rate. Compound interest. Now, if you decide to leave that $105 in the bank for another year, what would the future value of the original $100 be? So you take the original investment for 1 year, which is your $100. Your interest, remember from the previous slide, is 5%. So you take that $100, times it by 0.105, and you come up with 105. Now the second year, you take that 105 and you times it by the 5%, and you gain you get a quarter more. So after 2 years, you will have $110.25. You take the $5 from the first year and the $5.25 from the second year, and you add them together, and that's what compound interest is. Just to recap, when computing compounding interest, I would like you to remember that for greater than 1 year, remember that the interest in the next year is being paid on the interest. That's why you will see the 105 converting down into the second year and multiplying that by the 5%. So let's explore a little bit further. Your child, son, grandchild, spouse even, gets $200 for his birthday. And the interest rate at a given bank is offering 10% per year, and you want to invest that for 5 years. So let's compute this out. You have, remember, $200 to give to the bank for 10% interest rate for 2 years. So you have a present value of 200. Now, we want to find out what is going to be the future. So you have 200 times 10%. That will give you $20. Again, from the previous slide, you take this $20, this is compounded interest, and you're going to times it by the 10%, and you're going to have $22. You need to add $20 and $22, and your grand total you will have will be $242 at the end of 2 years. I would like to go through some common terms used in the equation. Up here in the left-hand column, this is what your equation is going to be. So even though present value is not listed in the equation, present value, again, remember, is the beginning amount in any account, whether that be $250, $1. The I is the interest rate per year. So the I. The N is going to be to the power of, that means the amount of years. So if you're putting it in the bank for 30 years, that will go up in here. And future value, FV, is the value at the end of the number of years. So let's do another example with this equation. What is the future value for $68 for 5 years with an interest rate at 8%? So if you plug in all of this, you have a present value, $68. That goes right in here. You have 5 years, that goes for the N. And then you have the 8%, that goes right in here. So you have 68, 1 plus 0.08 to the 5th power. So when you calculate this out, you get this number here, and then you're going to times 68 times 1.46933, and you come up with a future value of $99.91. Present value. Suppose now you want to have $2,000 in your bank account 3 years from now. The current interest rate is 7%. What is the amount of money you will need to invest now? So this slide here is looking at, you know how much money you want to have in the future, which in this case is $2,000. You have an interest rate of 7%, and you want to know how much you need to put up front now in order to make that $2,000. So what we have here is we have future value, which is 2,000. We have our interest rate, again here is 7%, and we know now 3 years from now, which is going to be from the 3rd power. This is the formula used. So again, we have $2,000. This equals that. And then what we do is basic arithmetic. You want to, or algebra, you want to solve for PV. So when you divide this out, this is the number that you would need to put up front now, in hand now, to have $2,000 3 years from now. I want to place $200 into an account paying 3% interest rate. I plan on keeping this money in the bank for the next 20 years. How much will I have in my account in 20 years from now? So remember, I want to put in $200, 3% interest rate, and 20 years. So using the compounded amount factor, which is FV times PV. So I have $200, I have my 3%, and I have my 20 years. So I take my $200, my 3%, and remember here's the N. So I have 1.03 to the 20th power. And this is going to give me this amount of money, $361.22. So now I've just made with an earning of $161. So again, points to remember is when compounding for more than 1 year, the interest is being paid on the interest. The interest on the original dollar amount is known as simple interest. In summary, present and future values are important methods for any financial decision, whether it's for your own personal use or for any firm or organization that you work with. This process of finding the present value of future cash flows is referred to as discounting. You will hear that term over and over again. Discounting is a common term in the business world, especially when calculating for capital budget decisions. I hope I've answered some questions and made this a little easier for you to compute.